Hi, I'm Ivan Karnizis, Auburn Airport Manager and a member of the EAA Chapter 526. Auburn Airport is located about 50 miles northeast of Sacramento, California, in the foothills of the Sierras. The elevation here is about 1,500 feet, and we have a nice 3,700-foot runway and several hundred home-based aircraft. We're pretty proud of this little airport. And today we're going to do a little webinar for you on the AWOS system.
Auburn Municipal Airport Automated Weather Observation 1752 Zulu weather. Wind 200 at 4. Visibility more than 10. Sky condition clear below 12,000. Temperature 20 Celsius. 2.8 Celsius. Altimeter 29996.
Most pilots recognize the voice transmission that we just played. However, a lot of people don't know that you can also listen to it by dialing it up on the telephone. And we're in here right now in the control room for our AWOS setup here at the Auburn Airport, and we're going to go over the visual display to show you and talk about each component and where the information comes from. On the top line we see the date, the time, and the identifier for this airport, and the name of the display that's up here. There are many displays that we can have on this screen, but we're just going to talk about the main display here. Here we see a readout of the wind. The wind direction currently is 210 degrees. It's 7 knots. Gusts aren't shown because there aren't any, but the gusts would be the highest in the last 10 minutes. Wind speed and wind direction are 2-minute running averages calculated from a sensor outside, taking readings every second. Every 10 seconds a sensor outside takes a visibility reading, and what you see here is the average for the last 10 minutes. The visibility shown here is 10 miles or more, which is about as good as it gets for this machine. Density altitude is not reported here because it's within 1,000 feet of the altitude of the runway. The temperature in Celsius is reported here, and the dew point here, and then the relative humidity is calculated at 46% in this case and presented here. Today, as usual in Auburn, sky conditions are clear, but when they're not, they're reported in hundreds of feet here and on the voice message. This comes from samples taken outside by the instruments every 30 seconds and done over a 30-minute average. The current altimeter setting is 29.96. This comes from 2 barometric pressure instruments out in the field that have to agree with each other. All of this is presented through an uninterrupted power supply so that we have reporting constantly regardless of the weather conditions or power outages. At the top of the tower outside, located at the northwest end of the field, we can see several components. There is the wind direction vane sensor and the wind speed sensor twirling, the red obstruction lights to warn pilots of the tower's height, and the lightning rod to protect the electrical components here. The small 4-pointed star at the end of the S-shaped pipe is a UHF antenna used to transmit the raw data back to the control room. This data is electronically translated by the control equipment and broadcasted to the pilots continuously in a voice format. Lower on the tower, we see several devices used to both gather data and augment it. The cylindrical C-shaped object that's about 1.5 feet tall and about 8 inches in diameter collects rain and augments the information gathered by the visibility sensors. Below that is a U-shaped 2-inch diameter pipe which houses the probes for detecting dew point and temperature. The pipe enables accurate readings by shading and ventilating the probes. Under that is a box that collects information for transmission and checks it using logic algorithms. In the gray boxes to the right are the redundant barometric pressure sensors. The instrument that you are looking at now checks the visibility in the area. As you can see, the sensors are small and close together. It detects minute air particles and translates the data into the visibility reading for the airport. Spanning across the weather station, we can look at all of the instruments at the base and end up at the last instrument out here, which is what senses the ceiling or the bottom of the clouds up to a maximum of 12,000. We've seen all the components at the Auburn Airport, the outside instruments that gather the information and transmit it by radio wave over to our control room where we're located right now. And we've seen how it works. Perhaps the most impressive thing to me is not only the accuracy of all the instruments and how they're translated into reliable data for the pilots, but also the great pains that are done with the instrumentation to check and recheck the data so that it's presented accurately. Thank you for watching today. If you have any questions, you can contact the EAA chapter on this website with the contact information and send us an email, or you can contact friends at the airport or myself. I'd be glad to help you anytime with anything going on here at the airport.